All right, problem 4 should be pretty quick. This is a quick problem. I did an example problem like this last week. Almost, I mean, very, very close, almost identical to this problem in the video of the jet diving down. So let's do this one out pretty quick. A pilot with a mass of 90 kilograms performs a vertical dive, then pulls out of the dive with a curve radius of 1550. Before heading straight back up, the pilot enters the dive with the speed of 250 meters a second. What is the apparent weight of the pilot at the bottom of the maneuver? How many G's would this be? Okay, so very similar to what we did last week. Now this is asking, actually, I just want to point something out that I didn't point out last week. It says how many G's? How many G? That's little g. That's little g. How many G's? You don't have to know the mass of the pilot. And I said that last week, but I didn't point out why. You don't need to know the mass of the pilot. And the reason is because when you figure out how many G forces that would need the mass of the pilot, and you compare it to how many G's it is compared to the pilot, all right, what am I talking about? I'm talking about this. If you compare the weight of the pilot to the G forces on the pilot, so let's go ahead and do that, 90 kilograms, and let's see, pilot pulls out, it's going 215 meters per second squared. Remember, this is our FC equation. Remember, FC equals mv squared over r. Our weight equation is mg. So mv squared over r, 1,550 meters. So the force applied to the pilot is 215 times 215 times 90 divided by 1550, 2684 newtons. The weight of the pilot is going to be 90 times 9.8. So 90 times 9.8, 882 newtons. So that's what the pilot weighs. This is what the pilot is experiencing. So what it means by apparent weight is this is what the pilot would feel. So the pilot's going to feel heavier than what they really weigh. So they're going to feel what's their apparent weight? Because that's the answer to the question. That's the apparent weight. But how many G's would this be? So you don't need to know the weight of the pilot to figure out G's, because we're going to divide the force on the pilot by the weight of the pilot. And if we have, this is what we're doing. We're taking this equation, the force on the pilot, and dividing it by the weight of the pilot. And if I take this, multiply by the reciprocal, m, boom, cancels out. So I don't need to know what the mass of the pilot is. It's irrelevant. So in fact, when you're talking about G's, that's an acceleration. Centripetal acceleration is v squared over r. I can figure this out just by knowing the velocity of the plane and the radius of the turn. I don't need to know the mass of the pilot to figure out G's in terms of acceleration. But we had it, so let's use it. And let's solve. And you get an answer and move on. All right, that was pretty quick. So 2684, 2684 divided by 882. A little more than 3 times what they would normally feel. So 3 G's. If you were to figure that out just by using the little g part of the problem to get the G's in acceleration, then this would be, let's do the math, 215 times 215 divided by 1550. That's a 1550. That's not very clear. Be neat. And I come out with 29.8. Now you know that's greater than 9.8. How many times greater than 9.8? About 3 times. So it's about 3 times greater than 9.8, so it's 3G. So you still get the same answer. This would come out to be, trust me you, but no, don't trust me, check it yourself, the same answer. So the pilot's weight is irrelevant. Any pilot performing that maneuver would feel 3 G's of force acting on their body. All right, quick problem.